everyone. Welcome to
Afternoon.
the session.
Afternoon.
All right, so let me just share my screen first. Okay, so what you're seeing on screen is the Form B course plan. So I'm starting with week 9, which is last week. I already uploaded for the homework, yeah. Okay, so homework is to configure CDP, LLDP, and NTP. If you notice this CDP, LLDP, and NTP, basically CDP and LLDP are both protocols for for discovery. Yeah, well, CDP stands for Cisco Discovery Protocol. So CDP is Cisco's proprietary protocol. Um, the open standard protocol is LLDP. So either one lah. Huh? If um, your company is using fully Cisco, then probably you'll use CDP. Okay, but if you mix, then probably you use LLDP, right? Because they basically those those intermediate devices like switches and routers, they report their information, right? To enable, for example, if you're the network administrator, to enable not only you but also other devices to find out what is the topology of the network. To know about the topology means you need to know what are the intermediate devices connected inside your network, right? So the homework is all the three, right? All packet tracer exercises. Now, NTP is Network Time Protocol. It's a way to synchronize your devices and your host, okay, so that they're all basically synchronized in terms of time, right? So you can specify your own time, or you can use any one of the freely available, time server online. Yeah. Okay. So in fact, in Windows, right, it's been there for quite a while already. Yeah. One of the way that you can set your time is to set it automatically, which means your Windows OS will try to connect to the Microsoft's NTP, yeah, so that you get the correct time. All right. Now, some of the NTP servers, they are basically based on very precise clock lah. Okay, most precise, I think, is atomic clock stored in a few places, right? So this is very important, okay, for especially for servers. Maybe host is not too critical, but for servers, because they're and also some of the intermediate device, because they need to do some tasks. Some of those tasks are scheduled tasks, and to so that the schedule actually works properly, then their time should be accurate. So rather than individually setting the time on all these devices, you can set them to get their time synchronized to a particular network time server. So network time protocol is a way for distributing time. Yeah. So that's the third 10.3.4 packet tracer configure and verify NTP. All right. So this week's lab are these three files that's also already uploaded, and there are no homework, no homework for this week. And starting from this week, I think there's no more homework, right? So you can see week 11, our practical is revision on SBA, right? And week 12 also continue with revision on SBA as well, right? And in week 13, right, as schedule. Of course, the schedule of the skill-based assessment is not, I think I already shared with you guys, right? And you guys agree on Monday, isn't it? Evening, right? That's because we need to synchronize. But therefore, the practical for this week 13, instead of skill-based assessment, we're probably going to allow you to do revision, um, or to complete some of the incomplete packet tracer activities that you have not done. Right, on the last week, which is what week 14, will be used to give feedback on your SBA. All right, and perhaps make good as well. Right, we'll see whether need to do make good or not. Okay. Closer to the time, I will discuss about the calculation of the coursework marks. All right. Now, coming back to this week, right? So we have three exercises. When you look at the exercises, actually, only the third one actually is continuation from the previous week, which is configuring SCDP, LLDP, and NTP. The other two is not really something that as a concept, it's not difficult, basically, but it's need to be complete, to be done to complete your knowledge as a network administrator. Okay, so backing up configuration files is important just in case your router ever down, and then you normally have a backup router in the company. Usually we in order to prepare for any eventualities, we normally have a backup switch or backup router. So the quickest way to do to basically solve any downtime, right? So to reduce downtime is um, to save all your settings into a backup file. And when when there's a faulty switch or router, what you need to do is get your spare switch or routers, right? And hopefully the purchase is that you purchase the same kind, right? Same model and things like that as a backup. Then you can just restore, okay, restore back the configuration. So um, basically you don't have to redo all the configuration on the new machine, okay, and so that your network can go up and running very quickly. Okay, there's very little downtime. So that's why this packet tracer, basically backing up configuration files, is quite important, right? Second, right? Let's say usually when we get information from Cisco, normally if you purchase products from Cisco, usually you're on their mailing list, and sometimes they offer new version of their iOS image. The iOS image basically is the OS that's running inside the Cisco device, right? So certain version probably just include maybe a few updated commands or things like that. But most often, um, rather than providing new features, is usually a security patch, right? So if they discover any security problem with the device in terms of the iOS, then they will provide a patch. So you need to upgrade, right? So this is exercise is by using a TFTP server to upgrade the Cisco iOS image within your either switch or router, right? So these are our lab exercises today, right? So let's go and check out, yeah, backup first, yeah. Okay, backup configuration. So here, just very briefly have a look at the topology. We have a TFTP server here, switch, a router, okay, and PC for configuration. We assume this is a console cable for configuring this router here and another switch. All right. So let's look at the activity. Yeah. So in this activity, backing up configuration files, you have three parts. First part, to establish connection to your TFTP server. Then to transfer the configuration file from the TFT server. Okay, so that means you have a catastrophic incident. So you can see that you need to replace right? So replace the device, and rather than going through, okay, and reconfiguring by manual, we want to restore the configuration from the TFTP server into your device. So transfer configuration file from TFT server. And then for part three, we'll do backing up, right? So we go through the process of backing up the configuration and the iOS back to our TFTP server, right? So as a background or scenario, in this activity, you're going to restore a configuration from a backup and then perform a new backup. So this is the restoration, right? And then this is the backing up, okay, new backup, right? So in this scenario, as I mentioned, we have equipment failure, right? To avoid downtime, we quickly get a new router that's already as a spare, and we replace the faulty router with the new router. Of course, the new router probably is still at factory default setting. Okay, no configuration has been done. Fortunately, you've been backing up the previous configuration. So the backup configuration is actually saved in the TFTP server. So you're going to do the restoration, right? Okay. So just follow the instruction. You can see that the commands is already provided for you. So you just go through the commands, but you do need to answer a few questions. So I suggest, as usual, select everything, copy and open your Word document and paste it inside so that you can answer and use that to answer um, the questions from this exercise. All right. All right. So this is the command that you need to do. Okay, to transfer. Okay, the configuration file. Obviously, you need to make sure your connectivity to the TFTP server is fine, right? So there's a few things you need to do here, right? So that your connection to the TFTP server is working, right? After that, do the transfer of configuration file and answer the questions here. Okay, right. So of course, for example, issue the appropriate show command. So you have to decide what show command to see the interfaces and check whether they are all up or some of them are down or whatever. Answer here, right? Then if you find any issues, then you correct the issues, right? And document it under D. Okay. Part three is okay, everything is working. The router is now working, connection is established because you have restored the previous configuration and the new router is now using that new configuration. It's working fine. So now you want to do a backup, right? So this part three, just follow through, okay, and answer any questions to do the backup. And once you do that, this exercises is done. All right. So it's not that difficult, right? But this is a very important part of your management of your network, right? Okay, so that there is no downtime. Okay, a lot of times, sometimes we depending on the requirements from the company, whether they able to provide budget for a duplicate device, right? But mostly, if the requirement is to minimize downtime, right? Even if you already put redundancy in, you still need to replace. So once the configuration is correct on a particular device, rather than you need to redo it again, the best way is to do backup and restore. Okay. All right. So that's the first exercise, and the second exercise is you know backing up. Yeah, backing up the Cisco image, the iOS. The iOS is the operating system, yeah. So if you've done any sort of update, so for Windows update, it's actually quite quite easy nowadays, right? And it can even work automatically at the background, right? but here you need to initiate. Okay, in this one is slightly different from how normal OS is being upgraded. Doesn't matter whether it's Windows or Linux. Okay, this is more akin to how you upgrade your mobile phones. Have you ever had opportunity to upgrade your mobile phones from one version of Android OS to the other version, the new version, right? It's basically you have to apply, right? You have to apply and then you have to restart and then you can see that it's updating. Yeah, but the newer Android actually they put the new copy into a separate partition and you can see that um, the for newer Android, the update process is quite it's quicker and more trouble free. Like I can see it. But here it's the same thing. You have a new image. Okay, so an image is basically a single file. Okay, that is like an archive, right? That contain all the iOS files, right? Okay, so that's why I said is basically very similar to Android process of updates rather than Windows process of updates. All right. So let me just go to the instructions here. Right. You can see here is we are going to use TFTP server to upgrade a Cisco iOS image. iOS image being the Cisco device um, operating system. Yeah. So basically, when you type your commands inside the switch or router, you call them or iOS commands. We're actually interacting with the operating system. Okay, for the life of me, I still wonder why Apple have not sued now Cisco because the OS name is the same, iOS, so similar to Apple. Anyway, you can see here the TFTP server connected to a switch, and then the switch connected to two routers, router one and two. And here we got the information here, the interface, IP address, and mask and default gateway. All right. So our objective for the first part is to upgrade an iOS image on a Cisco device. Okay. And then after that, we perform a backup of that iOS image back to the TFTP server, right? So this is a better way. Usually, I will imagine if I'm a network administrator, I will keep different copies of different iOS images within my TFTP server in a different folder, so it's organized nicely, right? So if after upgrading I find there's a problem, I can always restore the previous version, right? It's a nice way also to have a history of all the versions I have, right? Okay, so as you can see the scenario here, we'll talk about having backup copies of your iOS, not only the new one, right, to do the upgrade, but also the current one, just in case um, through maybe through hardware fault or through tampering or uh, mistakes, yeah, it causes corruption on the um, iOS, then you always have a backup, right? Always have a backup to restore, okay, to overwrite the faulty iOS image inside the switch or router, right? So scenario is, yeah, so we want to upgrade, yeah, Cisco iOS image onto the here. Let me see, yeah, Cisco devices, right? Cisco device, right? So in particular, we're going to upgrade on a router. Okay. So part one, we upgrade the iOS image on the router. You access the TFTP server, enable the TFTP service. Just click on it, go to services part, and then look for TFTP and enable it. Okay, so please note that there should be an iOS image file already existing on the TFTP server. Okay, can you answer this? This one, you can do your own research online. Which iOS image version on that server is compatible with this model of a router, 1941 router, right? And then from router 2, issue the command show flash and record the available flash memory. You will see that the iOS image is actually stored in the flash drive, right? Then perform copy of the iOS image version 15.5 from the TFTP server to R2, right? And then it's a command, okay? And then fill in the information, this information when the iOS asks you, okay? Right, so verify that the iOS image has been copied to the flash. How many iOS image should be located in the flash? Please answer that. Use the boot system. That means, does the old image still kept in there, or it's overwritten, or it's both of them are there, or one of it deleted? Okay, this is you have to find out, yeah, to answer this question, right? Then use the boot system to load the version that you have copied, 15.5. So this is a command to do that. Save the configuration and reload R2, means router 2. And then show version to see the version, right? If you done it correctly, you should see this version for 15.5, revision 3, okay, and M4A. All right, and you can see here, system bootstrap version 15.0 on RM9, uptime is and so and so and so and so. System image file should be the one that you already loaded here. Okay. All right. So now I want to upgrade the iOS image on the switch. Do this, well, basically practically the same thing. Go to the switch one and perform the copy and reload and confirm again by show flash to verify the new image has been loaded into memory. All right. And then part 2 is to do the opposite, to do the reverse, which is to backup. So copy from flash router 1 to TFTP, right? So then it asks you what is the source file name. You give it source file name. Here is all command line, so you have to be prepared. Okay, here is already given to you, so you just type and follow. But in normal situation, you have to take down this, okay, show flash, and then not the name of the image file, because you have to type it here, right? And then address of the TFTP server provided, and then destination. If you don't put a different destination file name, it will take the source file name, okay, as the destination file name, right? And then it will finish. Okay, then you go to TFTP server, check whether it is actually copied, right? This one it says you may have to stop the TFTP service basically to force refresh of the content of the TFTP server, just in case it doesn't show updated value. So just start and stop the service to refresh the content. Yeah. All right. So that's the second lab exercise. The final one is this. Okay. So continuation from last week's homework. Yeah, is to configure CDP, LLDP, and MTP as well. So let's see. Come back here, right? So in this one is a short one, right? Because there's nothing much, just to enable CDP, enable LLDP, and enable NTP server. Okay, right? So basically, this is it, right? So if STP has not converged yet, fast forward, click the fast forward button. It should be on the bottom left of your packet tracer. So if this one, fast forward is this. Sometimes when you're doing SBA also, if it takes a while to basically converge, like this one takes a while to converge due to the running of the protocol. Because this is a simulator, you can fast forward, okay? So it doesn't run on real time, on real time. That means you just make it run as fast as possible, this fast forward button, right? So that if you can't wait now, right? And then perform the configuration for LDP. After that, perform the configuration for CDP, and then perform the configuration for NTP. And that's it. Once all three are configured, then you're done. All right. Okay, so those are the three lab exercises for this week. Any questions from you guys?
No.
Noah?
No question.
No question. About you, Noel?
No.
Noah?
No.
All right. So you can start to do the exercises, practical exercises. Right? Anything, just let me know. Alert me by doing this. Okay, and ask your question. I will time to time I will check on you guys, see your progress. I'll be monitoring our chat here. All right.
Okay.
Okay. No, Kelvin, I think CR is carriage return. Basically, when you see the CR, you press enter, yeah? Is that okay? The CR, the CR on the, on the instruction basically indicates carriage return, and usually it means you press enter. So that means when destination file name, where is it now? Yeah, like this one, right? That means you don't have to put in anything. Just press enter here. So the CR is press enter. Is that okay, Calvin? RTA config error opening accessing 171.16.1.2. Okay, so did you enable the TFTP server? Go to the TFTP server, enable the service. Make sure that your TFTP is reachable. Yes, enable the service. Go to TFTP server, click the tab. For example, let me just go to here. Right. Services, TFTP. All right, so it's already on, yeah? For mine, it's already on. Then you go, there's a RTA config there. So you should be able to, you know, there should not be an error. Yeah, it should be there. See, RTA config is there, and TFTP is on. So should be, and I think let me just check the services desktop. Yes, the IP configuration 172.16.12. That's correct. So should be able to access it. Yeah. So this one correct. This one correct. Source file name. This one correct. Press enter. Should be okay. Huh? Oh, by default is red. Huh? That means it cannot go. Means you have to do this part. Click PCA, then desktop tab, followed by terminal to access RTA command line. Configure and activate the gigabit Ethernet 00 interface. Right, IP address should be matched to the default gateway for the TFTP server. Test connectivity to TFTP server. Right? Oh, yours green already, ah? Mm, so from the RTA, the router, do this, do this command, type this host address. It's confirmed there. Then source file name RTA config. There's no I, yeah? You can see there. You sure you do, did you put I? Be careful. There's no the RTA config. There's no I. Is that okay? Does it solve? Yeah. Oh, okay, okay. So that means this one, right? The config. There's no I here. All right. I don't know. Usually, typical command line interface. They always try to you know, be very short when they come when it comes naming. They always cut it short, right? But good for you to highlight this, right? So the others, because we typically one letter doesn't really make a big difference, right? But in this case, yes, that's one letter. Uh, okay. All right. So you can proceed, Kelvin. Okay. How about Farah and Noel? You guys okay? Did you notice that naming?
Yes.
Yes, okay. All right. Okay. Continue. Oh, still in week 8. Okay. All right. That's all right. Still got some time to catch up. Oh, I noticed that Farah and Calvin, you have not been submitting, yeah, right? So if you have done earlier ones and which one you've done, please submit, yeah.
Okay.
Hmm.
Hi friends, welcome to all. In this video, we are going to solve this packet tracer activity WAN concepts. Before coming to this activity, friends, if you like to get any CCNA version 7 support or any technical support, you can contact our team using our website. Link you will get from the description below. And see, if you like to get these type of technical videos in future, consider subscribing. And don't forget to enable that bell icon so that you will get notification message whenever we upload a new video. Perfect. Back to this packet tracer activity. Here we can see the objectives. In this activity, we will investigate various types of WANs by exploring a topology that uses diverse connectivity technologies. Describe different WAN connectivity options. We will go to the background. We will explore WAN technologies that are used to connect businesses and home users to data services. Note, there is no scoring in this activity. Okay, so as I specified, there is no scoring in this activity. Just we will explore about WAN technologies. So coming to instructions, part 1, investigate consumer WAN technologies for home and mobile devices.
Oh yeah. Hang on there. So coverage wise, let me just confirm. I will imagine that all of the um, you know, all of it will be covered. But let me just double check. Okay, yeah. So for SBA, it will be chapter 1 to 8. Okay. Okay, Noel.
Step 1. Explore consumer WAN technologies. In this step, we will explore 3 consumer WAN technologies and home networks. Look at the 2 home networks. What are the WAN technologies in use? Coming to this topology, here we can see business WAN, and here we can see consumer WAN technologies. And here we can see home DSL network. So here in this consumer WAN technologies, we can see they use cellular network, home cable network, and here in we can see here they use a home DSL network. Examine the connections used in the network topology by selecting the connections icon, the orange lightning bolt in the PT devices menu. Hover over the media icons to display their names in the white box at the bottom of the PT window. What media is used to connect the 2 home networks to the ISP? What devices in the home networks are directly connected to the ISP? Coming to this topology, here we can see the connections option, and here we can see they connected using these cables, home cable network and DSL modem. We can see the connections. We'll go to connections, and we will see they connected from ISP to this DSL modem using this phone cable. So they use this phone cable from ISP to this DSL modem, and here we can see from ISP to this home cable network, they use this cable, coaxial cable, which is connecting to this coaxial splitter. And actually, this smartphone is connected to this cell tower, and cell tower and ISP is connected using this coaxial again. Perfect. Click the DSL modem and ISP to this DSL modem using this phone cable. So they use this phone cable from ISP to this DSL modem. And here we can see from ISP to this home cable network, they use this cable, coaxial cable, which is connecting to this coaxial splitter. And actually, smartphone is connected to this cell tower, and cell tower and ISP is connected using this coaxial again. Perfect. Click the DSL modem and open the physical tab. What ports are available on the device and what is connected to them? Okay, we will click on this DSL modem here. Here we can see DSL modem, and I will zoom in. Okay, and here we can see two ports. One is a fast Ethernet 0 and line 0. So obviously from this ISP telco, it's connected to this DSL modem using this line 0. And here we can see this side. This wireless router is connected to this fast Ethernet 0. So obviously from this ISP telco, it's connected to this DSL modem using this line 0. And Here we can see this side. This wireless router is connected to this fast Ethernet 0. What is the purpose of the DSL modem? Obviously, DSL modem converts the telephone data network signals to Ethernet for the home network purpose. Next is what is the purpose of the DSL modem? Obviously, DSL modem converts the telephone data network signals to Ethernet for the home network purpose. Next is what is the type of connection between the ISP-telco-cable company network and the home cable network? Why is the splitter necessary? Yeah, here already we have seen they connected using coaxial cable. And here the splitter is necessary because the cable carries both the digital data and video signals. The splitter splits the media so that the data signal can be sent to the cable modem and the video signal to the TV. Using coaxial cable. And here the splitter is necessary. Next is what is the type of connection between the ISP-telco-cable company network and the home cable network? Why is the splitter necessary? Yeah, here already we have seen they connected using coaxial cable. And here the splitter is necessary because the cable carries both the digital data and video signals. The splitter splits the media so that the data signal can be sent to the cable modem and the video signal to the TV. Next is look at the ports on the cable modem, and what does the cable modem do? What connections does it have? So coming to our topology, here we can see our cable modem. We will click on it, and here we can see its port. Let me zoom in, and here we can see two ports. One is coaxial and one is fast Ethernet. Zero. So this coaxial port will connect to this coaxial splitter, and here we can see fast Ethernet 0, which is connecting to this wireless router. And here this cable modem converts the cable data signals to Ethernet signals. Here next is which, and here this cable modem converts the cable data signals to Ethernet signals. Here next is which port does the cable from the cable modem connect to on the home wireless router? Where did the interface IP address come from? So coming to this wireless router, we can see it got an internet port here. So from this cable modem, this cable, I mean this UTP cable will be connected to this internet port. And obviously this wireless router will receive its IP address using DHCP from the ISP. Face IP address come from? So coming to this wireless router, we can see it got an internet port here. So from this cable modem, this cable, I mean this UTP cable will be connected to this internet port. And obviously this wireless router will receive its IP address using DHCP from the ISP. Okay, next is look at the smartphone. Yeah, here we can see our smartphone, which is connected to this cell tower. What is its IP address and where did the IP address come from? Okay, let me go to smartphone so that we will get its IP address. We'll go to desktop and command prompt. Here we can give the command IP config/or. But here we cannot see any IP address. Let me go to IP configuration and this field is empty. The given static actually should get from DHCP, and let me give this a DHCP here. We can see the smartphone is connected to cell tower, and obviously the smartphone will get its IP address from this ISP bar telco. So actually we are not getting the IP address here, and we can see it says DHCP request failed. Okay. Yeah, here for the smartphone I'm not getting any IP address. So whatever address you get, please comment in the comment box, or if you are facing the same problem, please comment below. And we can see it says DHCP request failed. Okay. Yeah, here for the smartphone I'm not getting any IP address. So whatever address you get, please comment in the comment box, or if you are facing the same problem, please comment below. What data service is the cell phone currently using? Cellular data or Wi-Fi? So we can see here they specified a cellular network. So obviously it's a cellular data like 3G, 4G, now 5G is ready, right? Now coming to step 2, explore the business van. So coming to topology, here we can see this business van. In this step, we will explore the business van. The business is a retail tire store. It has a local headquarters. Where most of the business functions occur, and 3 stores that are connected to the business van. Look at the connections menu. What different types of connections do you see in use in the business network? Here we can see from ISP bar telco, they connected using serial. And also we can see they used copper, and here we can see they used fiber. Next is open the physical view for the StoreNet switch. What types of interfaces are present using serial. And also we can see they used copper, and here we can see they used fiber. Next is open the physical view for the StoreNet switch. What types of interfaces are present? You may need to zoom and scroll the view to see. Yeah, perfect. So we will click on this StoreNet switch. Here we can see that. And here is our physical tab. And just I will zoom in so that we can see its ports. Here we can see power supply. Okay. And we have this port, but it's not highlighting. Yeah, here we can see something C3650 built in. Yeah. And here we have a GLC-LH-SMT. Okay. And this is a GLC-T. So here we can see the GLC-T. The 1000 base -T SFP operates on a standard category 5 unshielded twisted pair copper cabling of link lengths up to 100 meter. And here we have seen this GLC-LH-SMT. The 1000 base LX-LH SFP operates in gigabit Ethernet ports of Cisco Industrial Ethernet and smart grid switches and routers. Yeah, perfect. So this we have seen GLC-T. Yeah, it's already told. Okay, which interfaces and media are used to connect the store networks to the business headquarters network. Why was this done? So here we can see these local networks which is connected to this store net, and we can see the stores are connected to the store net switch with Ethernet over fiber optics cables, right? So we can see this cable here. This was done because of the distance required to reach the stores. Local networks which is connected to this store net, and we can see the stores are connected to the store net switch with the are used to connect the store networks to the business headquarters network. Why was this done? So here we can see these local networks which is connected to this store net, and we can see the stores are connected to the store net switch with Ethernet over fiber optics cables, right? So we can see this cable here. This was done because of the distance required to reach the stores. In reality, another provider would provide this fiber optic service, but this has been simplified for the purposes of this activity. Okay. And obviously, you can guess when we have more distance between these local networks and store net, we cannot go with Ethernet. We have to go with Ethernet over fiber. What type of WAN service is used to connect the business headquarters router to the ISP? Yeah, here we can see from this ISP dash telco, they use the serial connection to this business headquarters. Coming to part 2, explore connectivity. Ping devices within the business WAN and the customer WAN networks. Also ping between the networks and the web server. Okay, can all hosts ping each other and the web server? Is this a good situation? Okay, we will test the connectivity. We will get the IP address of this web server. Desktop. I will copy this address. Then coming to any one of this PC from here, desktop command prompt will ping to that server. And we will see get the reply or not. Here we get the reply, it's working. We will go to this LAN, ping to the server. We get the replies. We will go to this LAN. We get the replies. Now we will ping from this PC. Okay, all networks here can ping to this web server. I mean this business headquarters or in this business WAN. Now we will ping from this network consumer WAN technology network. I will try from laptop 1. Yeah, there is my IP address. So I will go to command prompt and ping to our server. We are waiting for the reply. Yes, be able to ping. Even we can try from TV or laptop 2. Yeah, IP address there. Command prompt, we will ping to that server. So we may get request timed out. Yeah, we get the reply. So all networks from consumer WAN and business WAN can communicate with this web server, which is inside this which is connected to this ISP bar telco. Now we will ping from this business WAN to this consumer WAN. Let me get the laptop to IP address, and we can ping from any one of this network. Ping to this consumer WAN, and it says destination host unreachable. We cannot ping. Okay, let me get IP address from here. Okay, I will do one thing. Here I will give IP config/all, and we will get its IP address. Copy that. Then let me go to consumer WAN, and here I will ping from laptop 1. Ping to that PC, and we will wait for the reply. Request timed out. I think it's not working. No, we cannot communicate from this home to business or business to business to this consumer, right? So here they ask this question: is this a good situation? Obviously, we can say it's yes, because these networks should not be directly reachable from outside for security reasons. Okay, consumer, right? So here they ask this question, is this a good situation? Obviously we can say it's yes, because these networks should not be directly reachable from outside for security reasons. Okay, that's fine. So in this packet or activity, we have seen WAN concepts. Now, dear friends, if you get any doubt or if you have any suggestion,